Hello everyone and welcome to Beginner's Code. Today we will be looking at using Matplotlib and some simple math equations to create a graph that represents our data. Okay, so the first thing that we're going to do is just import a few libraries, and now I'm using Jupyter Notebooks for this. You don't have to, you can use whatever you like. But yeah, Jupyter Notebooks for me it makes it a lot easier to just easily run your code and see the data without having to keep running your actual file. So what I'm going to do first is just import the two libraries that we need. One is Matplotlib and the other is NumPy. So from Matplotlib, we want to import pyplot as plt, and then we want to import NumPy as np. And this just allows us to use the pyplot module as an alias of plt and the NumPy module as an alias of np. So now what I want to do is just create 10 or so different variables that all hold roughly the same numbers, but some of them are slightly different. So what I mean by this is the first will be a list of numbers from from 0 to 9. And then every one on from that will be that list times by a number. So to start with, we're just going to use A, and what we're going to do is use the NumPy arrange method. So np.arrange, and this is just an easy way of using the range module, but using the NumPy version. So we will now have an array of 10 different numbers from 0 through to 9. And now what I want to do is just times this, well, for B, I want to times this by 2, and then for C, times it by 3, and so on until we get to roughly about 10. So B is equal to A times by 2, C is equal to A times by 3, D is equal to A times by 4, E is equal to A times by 5, F times 6, G times by 7, H is by 8, I is by 9, and then J is by 10. Okay, so now that we have our different variables and the different data that's actually being used, what we now need to do is create our axes. And to do this, well, to start with, I'm going to use the plt.figure method. So I'll create a variable called fig, and this will be assigned plt.figure. And then what I'm going to do now is just create I'll start with by creating a set of axes for this figure. So axis 1 is equal to fig.add_axis, and this is just going to take in a list of 4 different integers or floats. The first 2 are the left and the bottom, and then the second 2 are the total numbers. So like the max height. So 1 is the max, 1 represents 100%, 0.5 represents 50%. So what we'll do first is just 0, 0, 1 and 1. And now if you're on something else like PyCharm or Visual Studio Code, then you will need to use the .show method. But for Jupyter Notebooks, you don't need to. But what I am going to do first is just use this command, and this just allows us to, it's basically like using the .show method. So if I run this, we now have our axis down here that goes 1 through to 1. There's obviously no data on it, but if I was to make this, say, 0.5, you now see how this has changed the actual shape of it. So now we have one axis here. I want to actually include a second that's inside the graph. And the reason for this is because at the very beginning we have the value 0. So 0 times by 2 and 0 times by 10 is still going to return 0. So at the very beginning they will all be bunched up, and then they will start spreading out further and further apart. So what we want to do is actually have a smaller subsection of the graph where we can zoom in on the data. So for this, what I'm going to do is create a second axis, and this will be done in exactly the same way, except from this time when we pass in the dimensions, we're going to do 0.25, so that will be 0.25 from the left, 0.65 from the bottom, and then we want to make it 0.3 or 30% of this size. So if I now run this, we now have a axis on the outside and then a smaller one just on the inside. So now we have our two different graphs. What we want to do is just start plotting. So if I do ax1.plot, and then now what we want to do is just pass in the value of a. So these will represent the value down here, so a will always be down the bottom. So one of these parameters has to be a because that's the x value. And then the second a represents where the data is going to be plotted along the x and y axis. So this one, because we are using a for both, we should have a very, very, not straight line, but it should be close to straight. So now if I run this, we have it completely diagonal. However, if I was to say put in the final one, so ax1.plot, and my bad, and then passed in the value of a and then j. So right now, if I run this, we will be comparing this line to a and j. And now you'll see that the original line that we had is a lot more straighter than it was, and that's because the difference between them has changed dramatically. So now if I start adding in the other plots to make this, to plot all the data on it, so ax1.plot, ab, ax1.plot, ac, I'm just going to copy and paste this a few times. So then we have D, E, F, G, H, and then I. And now if I run this, we now have a graph here with 10 different lines on where they all start very, very closely together and then spreading out. And as it's times by a different number each time, there is a small gap or a small increment between each line, and it's evenly distributed. Whereas if this was, say, times by or raised to the power of 2 and then raised to the power of 3 and 4, then this would be a completely different looking graph, because raising the numbers to the power of 10 will astronomically affect the data compared to raising the values to the power of 2. Okay, so now we have our data actually on the big graph. What we want to do is just add some labels to it so we can differentiate what each line is. So if I do label is equal to x, because we are just using x, and then label is equal to times 2, and then label is equal to 3, label is equal to 4, times 5, times 6, times 7, times by 8, times 9, and then times 10. So now if I run this, we get absolutely nothing back, and that's because we need ax1.legend. And now if I call this, we now have a legend here on the left-hand side which tells us which line represents what. So we have here this blue line, which is x, or the value of a, and then we have here this orange line, which is a times 2, which is here, and then a times 3, a times 4, a times 5. So now we have our outside almost set up. What we need to do is try and set up the inner one, so this smaller graph that's inside. And to do this, well, we've already created our axis 1 and our axis 2, and we've plotted on our axis 1. So now what we want to do is plot on our axis 2. So now if I just copy and paste this, and then I'm going to go through and change these to axis 2. And then if I run this, because everything is exactly the same, we now have exactly the same plot, but on a much smaller scale inside. So now what we can actually do is create a limit for the value where we want to start and where we want to stop. So you'll see down here the value of x, or the x-axis, goes the whole way through to 9. Whereas what we mainly want to focus on is the values of 0 through to potentially 3 at most, and maybe up to about 25 at most, maybe. So what we want to do is just give it some limits. So if I do axis 2 dot set underscore xlim, and then pass in a list, and in the list we want the start and the stop basically. So we want to cover the start of 0, so we want the value of 0, and then we want to go all the way through to the value of, we'll say 2 for now, we'll see how that looks. And then if I do the axis of 2 dot set ylim, and this will be the same but for the y-axis, so this axis here, and we want to start at the bottom, maybe at most 25, but I reckon probably about 15 for the moment. So if I do 0, 15, and then if I run this, we now have this much closer in, and this allows us to actually kind of distinguish or extinguish how the data is actually represented at the very beginning, because it's so tight down here that you can't really see it that well. So it's quite nice having a really zoomed in version. For example, we could go even further in and have it through 0 to 1 and then 0 to 0.75, and this really does break it down a lot easier, which is nice. So now we want to just finally give our axis, or our figure, or our graph, sorry, a couple of titles. So we want to label our x value so that we know what the values are. And obviously we have the ticks down here that go through 0 to 9. So now if we just did ax1 dot set underscore x label, and then we just pass in value of x, and then we want to do the y label. So ax1 dot set underscore y label, and then we'll just pass in the results of x times by 1 through 10. So result of x times 1 through 10. And then finally we want a title for the whole thing. So something along the lines of value of 0 through 9 times 1 through 10. So ax1 dot set title, value of 0 through 9 times 1 through 10. And now if I run this, we will have 3 different titles, or 3 different labels. So we now have value of 0 through 9 times 1 through 10. We then have result of x times 1 through 10. And then we have value of x. And this gives it a lot more information towards what this graph actually represents. But we can also do, say, ax2 dot set underscore title, and then pass in zoom on values of 0 and 1. And we might need to just bring it down ever so slightly. So if I bring this down to 0.6, and then, so now we have a little crossover. So if I change this to 0.2, okay, so it's now evenly spaced, which is good. Zoom on values of 0 and 1, which is true, so we're on 0 and 1. So that is an easy way, or not an easy way, but that is a way of easily representing how our data can be changed and how it can actually be visually represented through something like Matplotlib using object-oriented programming for it. So the actual way of fig equals plt.figure is a version of Matplotlib that uses object-oriented programming, and this allows for more than one use of the axis, which we have here on the inside. Thanks for watching. Hopefully this has helped your understanding on how we can use Matplotlib in many different ways to create enticing and easy to read graphs for our data. In the next video, we will be looking at object-oriented programming part 2 and how we can use it to improve our code. If you liked what we've been through today and you want to learn more, then please drop a like and subscribe to my channel. Or if there's anything you'd like me to cover further, please don't hesitate in reaching out to me on Instagram, on YouTube, or through my website. Thank you, and see you next time.